There are multiple ways to solve logarithmic and exponential equations, but we are going to use these 5 steps for every single different type of equation. They will work every single time. So let's do some examples. I think that's the easiest way to see this in action. All right, example 1. Solve 2 times 3 to the 7x power equals 54. This is 3 to the 7x power. The 2 is not to a 7x power, so do not multiply that together to make your base a 6. Do not multiply anything together. This is a base, and this is a coefficient. Instead, our first step says to isolate. We need to get this piece by itself, this exponential part. So I want to isolate it. I need to divide my 2 over. 2 times 3. So if I need to get rid of it, I would divide 2 over. All right, next we need to convert because our x is in the exponent spot. So the only way for me to solve for x is to move it out of the exponent. And so the way to move it out of the exponent is to convert. You can convert using either of the methods I've shown you before. I'm going to use method 2 because it's going to help us a lot in our next video. So this is base 3, which means I want to put log base 3's in front of both sides of the equal sign. Now, on the left-hand side, log base 3 and base 3 cancel each other out, and I'm left with just a normal 7x. And on the right-hand side, nothing cancels, so it will stay as log base 3 of 27. It's not bad to have that log base 3 in our problem still, because this is all calculator buttons. It's just numbers and calculator buttons. So let's type that into your calculator. Remember, if you don't have the ability to type in anything other than a common log or a natural log into your calculator, you may have to use the change of base formula, which is log over log, and the 27 is physically higher than the subscript 3, so that reminds me to type it in as log 27, close your parentheses, divided by log 3. So 7x equals 3. Last step, solve for x. I need to divide my 7 over to the other side, and my final answer is x equals 3/7. Now the check step here isn't as important when we start with exponential functions, but it is always a good idea to check your work. So you could check your work by subbing in a 3/7 here for your x, and just make sure you actually get 54. Perfect. Let's do more examples. All right, example B. We want to start again just like we did before. We need to isolate this exponential piece. So I'm going to subtract my 7 over to the other side. Now convert. I convert by putting natural log bases in front of both sides here. E is my base, so I want to use a log that also has a base of e, which is natural log. The reason I do that is because on the left-hand side, natural log, which is log base e, and base e cancel each other out. And on the right-hand side, I have natural log of 200. This is all calculator buttons. Everyone should have a natural log button. If you don't, you can use change of base. And I'll get 4t minus 6 equals 5.30. Solve for t in this case. That means I need to add my 6 over to the other side before I divide by 4. And my final answer is 2.83. You could double check your answer by plugging that 2.83 back into the original equation and make sure you get a 207. All right, I'm going to try and go through these last two examples a little bit faster. Isolate. That means I need to subtract before I divide. Even though it's written a little differently with parentheses, as opposed to the example above where I used the dot, it's still the same idea. I'm just trying to isolate the base 4 to the exponent. That's an x squared. All right, step 2, convert. I am going to convert by putting log base 4s in front of both sides. So that way on the left they cancel. And on the right hand side, this is all calculator buttons. Log over log. The parentheses is physically higher than the subscript. So type that into my calculator. You should get a 1. And now solve for x, so I need to square root it. Don't forget, if you write a square root into an equation that did not have 1 originally, you need a plus or minus. The square root of 1 is 1. So I have two answers here. I have a x equals positive 1 and x also equals negative 1. You could double check your answer by subbing it back in to the original problem. All right, and then last example. Okay, step 1, we want to isolate our exponential piece. That means I need to subtract 6 over to the other side. Step 2, convert. I'm going to convert by putting log base 2s in front of both sides. So this will simplify. And the right-hand side stays log base 2 of 3, but that is all calculator buttons. I may use change of base here. The parentheses is physically higher than the subscript, so that reminds me to put the 3 on top. And now solve for x, or subtract your 4 to the other side. Check your answer. You could plug the negative 2.42 back into the exponent and you should get a 9.